is Senan Suleymanli, and I would like to first thank Enver Mehmetli for inviting me as a speaker. And I would like to thank you for coming here and attending the symposium. Enver told me that, Senan, you will be a speaker and you should talk about the process engineering. And you should talk in a such way that everyone will love process engineering. I said, okay, I will do my best. Then I chose the biodiesel production because it's green, it will be more effective, it is safer. Also, Azerbaijan is an oil and gas country, but we know that, especially in Europe, there's a lot of the research is going on the biodiesel, and also biofuel is really famous in the USA. The production increases yearly, and also research and research papers published increase yearly in this context. And I will try to put a frame from process engineer work in my slides to show you how a process engineer thinks. First, a short information about me. I got my bachelor degree at Kafkas University, which is now called the Baku Engineering University. Then, after that, I moved to the Netherlands to do the master's in chemical engineering, and the track was the process engineering. TU Delft was a research university, so my courses was based on the research, and I also loved research at TU Delft. My research project was about the kidney stones. I am also interested in the biofuels. Now I am back and I work for the state oil company of Azerbaijan, which is known as Socar. I am a process engineer at Heydar Aliyev Oil Refinery, and now we have a modernization and reconstruction project in the refinery. We want to produce more gasoline or diesel with high quality. Okay. Have you ever thought, what does an engineer do? A simple answer. My answer would be the engineer solves problems. So then different disciplines, mechanical, mining, chemical, and others, electrical, solves the problems in different contexts. Then we should know our problems, what are our problems, to be able to solve them. What kind of problems do we have in process engineering? I can also convert it to the different types of companies. Mainly there are two different companies, such as the engineering companies. These companies work on the project. There's no plant, nothing else. They just design it, do all the engineering and construction works, which is known as EPC contractors, engineering, procurement, and constructions. Once there's a plant there, it is all constructed, then operating companies operate the plants and do the production. So Socar, Foster, Wheeler, Wood, Technip, Worley, there are hundreds of engineering companies all over the world. The engineers in these companies mainly work in the offices. They do calculations, simulations, and then operating companies take over the job. You know, Socar, BP, Total, BASF, Socar Polymer, and also hundreds of operating companies that produce different products. In operating companies, engineers work mainly at the plants. They wear PPE, personal protective equipment, and then they work in the sites. And now let's go back to biodiesel production. Why biodiesel? I just said it is greener, and we need greener products to use in order to save environment, as Enver gave his message about the environment. You can see the chemistry here. I am not going to bother you with much chemistry. I know not many people love chemistry, but what's interesting that at the schools, we know that this is a chemistry to produce, let's say, biodiesel. We just write on the one sheet of paper But when it comes to the industry, it is not that simple. There's a lot of work should be done. And then, this is the process for biodiesel production. How terrific and scary is it, right? So, basically, if you are not a chemical engineer or process engineer, it is really hard for you to understand when you see this scheme. But we are engineers. We don't memorize, but we can solve the problems. We should also make the problem simple for others to understand it. So from now on, we will all be process engineers and construct this process flow diagram together. To construct it, we need blocks. Which blocks? Tank, heat exchanger, decanter, mixer, pump, centrifuge, reactors, column, and absorbers. You know that we will use this equipment to construct our process flow diagram. If we think that what we need and what we are going to do, we can construct the PFD together, and then it will be really easy for you to understand it. Okay. We need raw materials. Raw materials for biodiesel is oil, fat, and we also use the methanol. And then we know where we are going to do. We will start from here and we go here. We have biodiesel, which is our main product, and the glycerol, which is a byproduct, but it can also be sold. Okay, next step after the feed section is a reactor. We have a reactor, and to start the reaction, we need certain temperature and pressure. Then, obviously, we need the pumps to increase the pressure for the raw material coming from the tanks. And then we have low temperature, we need to go, okay, before the temperature, we have a mixer, just to be sure that our raw products mix well. And then after the mixer, we put a heat exchanger to increase the temperature until the desired one, which is, in this case, is around 50-60 degrees. We have a reactor, and we have our raw material in a reactor. But we have a problem. Problem is that the first reactor esterification reaction is a slow process. So we need a fast reaction so that to achieve the desired product fast. That's why in chemistry we use catalyst. We add catalyst in the raw material and then send to reactor together. So after the reactor, there is never 100% reaction. You have always the mix of products after the reactor. So this is a decanter, kind of separation, one of the separation methods, and you want to separate your glycerol content from your feed to the next reactor. When you separate it, you will go to the second reactor, and then you need a heat exchanger, maybe if it is required a pump, again to achieve the certain temperature and pressure. But that's not enough for the second reactor where we have the trans-esterification reaction to achieve the biodiesel. We need more raw material, methanol, so it comes from here, and we need more catalyst here. When we send all of them to the reactor, this type of reactor is called the CSTR, which is continuous stirred tank reactor. Then we have reaction in there. We have our product. Again, it's a mixture. We have to separate it. To be able to separate it, we need to send it to the centrifuge. So process engineers know that they have to separate it, but it is important to select the process, which type of separation you need there. Basically, if you look at the scheme, we have reactor here, we have the reactor here, and the rest is separation. There are so many columns and different separation techniques used. So you should know the technology and apply in a correct way. Here we again separate the glycerol and then send ester to the column. Separation is basically a physical separation. So you know distillation, but in distillation columns it is more complex. You can get several products here. And then you have a distillation column. For gravity, you know that you will get the lighter product top and the heavier product from bottom. Okay, we have recycled methanol. We should use a lot of methanol in order to have a fast reaction. But if you use more methanol, we will have more methanol mixture in the final product. But we don't want to lose it. We can just basically recycle it and reuse it. The bottom product, crude biodiesel, is sent to the absorption section. In absorption, if it is a gas, of course, it enters from bottom and it will go up. Then we can use water to wash it. Water will wash it and take all the impurities with it and leave from bottom. And then we have a pure, cleaner biodiesel, which is called a wet biodiesel. Why wet? Why wet? Because we have water in the biodiesel. Then we still need to separate that water from biodiesel. Again, we can use a centrifuge to separate it. And then we have the mixture of the glycerol, methanol, water from the centrifuge. Now you see that we take the glycerol phases from different separators and then we collect them here. We can add acid, get rid of all the impurities such as the fatty acids or other impurities, and the glycerol. You need the pH control for glycerol. That's why it is sent to the specific tank to control the pH of glycerol. Again, we need some base to control the pH. Then the crude glycerol is sent to, again, for separation section. These are all columns, and we separate the lighter products. We have still methanol in the glycerol. We want to reuse the methanol. That's why methanol leaves from top and goes all the way back to the tank, or to the to the tank. From tank we can reuse it. Glycerol with 50% goes to the next column. In the next column, we can separate the water. You can ask, okay, how we can have the methanol first here, but not water here. Water leaves from bottom, but here water will leave from top. It is all about the operating. You can operate at temperature and pressure in order to have the specific products at top or bottom. Then, again, we can reuse the water. It goes back to the other absorption. And then we have the glycerol with 85%. We can sell it to other companies. They will purify it more, get 95, 99 degree percentage glycerol, and then use it. Okay, let's go back to our main process. We want to produce biodiesel, not glycerol. After the centrifuge here, we separated the heavies, then we have the biodiesel. It is sent to the evaporator, and using the vacuum, we can evaporate all other impurities, and then we will have the biodiesel in the end here. So I hope now this process scheme is now cleaner for you, because we tried to construct it together. In reality, this scheme is much more complex. You have a lot of equipment, hundreds, maybe thousands of equipment. You should know which one to choose and where to put. But that's not all, because that's only one frame from process engineering. You see, there are a lot of different types of jobs that process engineers do, such as doing simulations, doing the material balance, the heat balance, detailed engineering. You have to size all these equipment. But before doing that, I would advise the young generation of process engineers who are maybe still students to learn this equipment. If you know how this reactor works, how this column works, you will know in future where to put it and how to use it. And then, of course, math is essential for all types of engineering. You should be good at math. Probably some calculus you may need in future, especially if you want to continue in research. So these are all different types of work that process engineers do. Machine learning, electric technology, you should work with software, robotics is coming to our new life, network solutions. And then, just one more example that Dr. Baraka said in his presentation, there's processing in mining engineering. So process engineers actually can work where there is a process. If there is a process, you need process engineers to operate them, to handle them. Thank you for your attention.